Hello friends, this is Utkarsh back again with home assignment 2, question number 5. So the question number 5 goes like this. The customer flow at a grocery store can be viewed as a Poisson process. That is, the probability of the number of customer arrival in time 0 to t is equal to k. That is equal to e to the power minus lambda t into lambda t to the power k divided by k factorial. Suppose the probability that in 2 minutes at least one customer will arrive equals to 0.3. So there are 4 parts to this question. Find lambda. Second part, find the probability that in 3 minutes no customer comes. Find the probability that in 10 minutes at least 2 customer will arrive. And fourth, the probability that in 1 minute exactly one customer will arrive. So this question goes like this. The probability that number of customers arrived in time 0 to t is k. So k customers are arriving in time 0 to t, and the formula for that is e to the power minus lambda t into lambda t to the power k divided by k factorial. This is our base formula. So for first question, so what is given to us is like, so the probability of now the number of customers arriving in time 0 to t is equal to 1. So only one customer is arriving in time 0 to t 0 to 2, and probability of that happening is 0.3. So for first question we need to find lambda. So we have this information and we need to find lambda on basis of that. So that makes the equation like e to the power minus lambda 2. So because the time given is 2, so we substitute the value of t as 2 into lambda into e to the power minus lambda 2 into lambda 2 to the power 1. So as k is equal to 1, k is equal to 1, t is equal to 2, t is equal to 2, divided by, here it was k factorial was the number of customers arriving. So it's like 1 factorial is equal to the probability was 0.3. So probability is 0.3. After solving this equation, we get lambda is equal to 0.178. So we need to use this lambda for further questions. Second, find the probability that in 3 minutes no customer comes. So find the number of customers arriving in time 0 to 3 is equal to 0. So which gives us the initial equation was e to the power minus lambda t. T is equal to time. So e to the power minus lambda t, we have time 3. So 3 into lambda into t to the power k. So t was time, 3, number of customers arriving 0, 0, 0. So after solving this equation, we get answer as 0.586. We also need to keep the value of lambda which we find in the previous question here, and after solving this equation we get the value as 0.586. Okay, so now to the third question, third part of the fifth question. Find the probability that in 10 minutes at least 2 customers will arrive. So find the probability that the number of customers that will arrive in time 0 to 10 is equal to 2. So here it states that in time 0 to 10 2 customers will arrive. Here we have the formula e to the power minus lambda t is equal to time is 10, so e to the power minus lambda 10 into lambda t to the power k, where t is time, lambda and time is 10, so lambda into 10 to the power k, so k is the number of customers arriving, that is equal to 2. So lambda into 10 to the power 2 divided by k factorial, which k factorial is again the number of customers arriving, that is equal to 2. So it's 2 factorial. Keeping the value of lambda here, that is equal to 0.178, and solving this equation we get the answer as 0.513. So the probability of the number of customers arriving between time 0 to 10, that is equal to 2, is equal to 0.531. The fourth part of it, find the probability that in 1 minute exactly one customer will arrive. So the number of customers that will arrive in time 0 to 1 is equal to 1. Substituting these values in the above formula, like e to the power minus lambda t, where t is equal to 1, into lambda t to the power k, where t and k both are equal to 1 divided by k factorial, that is again equal to 1. Lambda is equal to 0.178. Solving this equation, we'll get the answer as 0.149. So the answers are like lambda is equal to 0.178. The probability that the number of customers arriving in time 0 to 3 minutes is equal to 0, and the probability of that happening is equal to 0.586. The number of customers arriving in time 0 to 10 is the number of customer arriving in time 0 to 10 is equal to 2, and the probability of this thing happening is 0.531. And finally, the probability that the number of customers arriving in time 0 to 1 is equal to 1, and probability of this thing happening is 0.149. So this was our fifth question of second assignment. Thank you.